Okay, welcome back to the nth episode because I don't know what episode this is anymore. Right. Mm-hmm. Okay. Okay. Mm-hmm. So we're gonna continue with sorry, YouTube episodes. And it's chemistry again. I think this is the fifth or sixth episode that I've been talking about chemistry nonstop. So yeah, let's continue. Okay, right. Continuing where we left off. Mobility. Well, gas molecules are always in state of continuous motion. That's true. They move from one place to another because of their high kinetic energy, just like a friend of mine who also becomes high because of sugar. They're they're everywhere. Okay. Okay, they move through empty spaces that are available for the molecules to move freely. Like random motion and mobility results in mixing up of gas molecules to produce a homogeneous mixture. Hmm. Next, the density of gases. Right, gases actually have a low density than liquids and solids due to light mass and more volume occupied by the gas molecules. Gas density is expressed in grams per tm, and it decreases by cooling because their volume decreases. Mm, Right, liquid and solid densities are expressed in grams per unit because liquids and solid are 1,000 times denser than gases. Interesting. Okay, that's finished. Okay, so I guess up to the next main topic. Physical states of matter. It says here about Boyle's law. I don't know why, but Boyle's law. In ni- in 1662, Robert Boyle, yes, studied the relationship between volume and pressure of a gas at constant temperature. A volume of a given mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. And the volume of a given mass of a gas decreases with the increase of pressure, and vice versa. Right. So yes, Boyle's law is actually yeah. This is the definition, the thing about Boyle's law. Boyle's law. It's stated as the product of pressure and volume of a fixed mass of a gas. It's constant at a constant temperature. I see. And the formula for that is P1 um, P1 V1 equals P2 V2. I think that's the one. Yeah. And also it establishes the relationship between pressure and the volume of gases. Alright. What else? The experimental verification of Boyle's law. Number 1. Mass of a gas in a cylinder having a movable piston and observe the effect of increase of pressure in its volume. It's the experimental verification, okay? Pressure of 2 atm is applied. The volume of the gas read as 1 dm 3 squared. I'll not read that for the sake of my understanding. Absolute temperature scale. Lord Kelvin introduced absolute temperature scale or a Kelvin scale. This scale starts from 0 K Kelvin or 207 degrees Celsius, absolute zero. The temperature at which an absolute zero is the temperature at which an ideal gas would have zero volume. Both scales have equal degree range. Therefore, when 0 Kelvin equals to negative 270 degrees Celsius, then Kelvin is equal to 0 degrees Celsius. Interesting. And I think we learned this in math. I think algebra. Is it? No, I don't think it was algebra, but we learned this in math, converting Kelvin and Celsius. So yeah, math and chemistry, technically the same thing.